This is worksheet 4 of the moles packet, and in this worksheet we're not actually going to introduce new information. We are going to put together what we learned in worksheet 2, which is that 1 mole equals a molar mass, and that's something that needs to be calculated individually for each compound. And then what we learned in worksheet 3, which is that 1 mole is equal to Avogadro's number, or 6.02 times 10 to the 23rd, either atoms, if we're talking about single elements, or we'd put the units as molecules if we're talking about things like water or one of our Hofbrinkel molecules. So, we're just going to look at 2 examples here, one going sort of each direction, but I want to refer you back to worksheet 1 so that you can kind of get an idea of where we're going here. So if you go back to worksheet 1, we had this chart, right? And you're going to be given a copy of this chart when you take your test on this unit, which is going to be really handy because you can actually use this to kind of guide your thought process as you set up these problems. So on worksheets 1 and 2, we went back and forth from grams to moles or moles to grams, and that's why we had to learn how to calculate a molar mass, that grams per mole number. In worksheet 3, we learned how to go from moles to molecules and molecules back to moles, and that required us to make fractions using Avogadro's number, right? So what we're doing in worksheet 4 is we're actually going to go from molecules to grams and from grams to molecules. Now, you'll notice on this chart, there's no arrow that goes directly from molecules to grams or grams to molecules. And that's your indicator that these are not going to be one-step factor label problems. So we're not going to have just one fraction, right? So it's kind of like in the factor label packet when you had a problem that asked you to go, let's say, from centimeters to kilometers. You looked on your conversion chart and there was no direct conversion that said exactly how many centimeters are in 1 kilometer. And so you had to set up 2 fractions, one going from centimeters to meters, and then the next one right after it going from meters to kilometers. So what you're going to do in these problems is if you're given molecules and asked to find grams, you're going to set up one fraction that gets you from molecules to moles using Avogadro's number, like you did in worksheet 3. And then you're going to set up another fraction right after it that goes from moles to grams using a molar mass that you'll need to calculate, just like you did in worksheet 2. And then, of course, like all of these worksheets, you could go in reverse, right? If you're given grams and asked to find molecules, same idea, opposite direction. Your first step would be going from grams to moles using a molar mass that you would calculate. And then your second step, your second fraction, would be going from moles to molecules using Avogadro's number. So that's the idea, and now we will look at some examples. So if I look at my first example, back on worksheet 4, right, it's asking us how many molecules there are if I have 90.1 grams, okay? And to kind of simplify some of these problems, I've bolded the information you really need to focus on. So your first step in each one of these problems is going to be to calculate a molar mass, just like we did back on worksheet 1. So if you're calculating the molar mass of water, there are 2 hydrogens that each weigh 1.01. You got that off the periodic table. There's 1 oxygen that weighs 16, and so you add it up, and 1 mole of water is equal to 18.02 grams of water. So Once you've done that, your second step is to set up your factor label. Just like always, we want to know how many molecules we have. We've been given that we have 90.1 grams. And so we're going to set up, I'd make this little picket fence so you don't get confused about what's on the top and what's on the bottom. We're going to set this up, and first we want to get rid of grams. So whenever you want to get rid of grams, you need to use your molar mass information. So this number right here, or this equality or equation, is going to get turned into your first fraction. We put the 18.02 grams on the bottom so that we could cancel out, and we're left in moles. So if I solved right now, I would be told how many moles are equal to 90.1 grams of water. That's not what I want. I want molecules. So my second step is going to be using Avogadro's number, which is always the same. It's never changing, so I don't have to do a calculation. I can simply say that 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. And now the only unit that hasn't canceled out is molecules. So I'm going to do my multiplication, 90.1 times 6.02 times 10 to the 23rd. And if you don't have an EE key, make sure that goes into parentheses. Hit enter, equal that out, and then divide by the 18.02. And you should get 3.01 times 10 to the 24th molecules of water. Okay? So we can go in the reverse direction. Okay, some of these problems will be in the opposite direction. So this time, instead of being given grams, that's what we're asked to find. And instead of being asked to find molecules, that's what we're given. So first step, as it always will be on this worksheet, is to calculate a molar mass. We're calculating the molar mass of ammonia. So I have 1 nitrogen. Off the periodic table, I can see it weighs 14.01. I have 3 hydrogens, so 3 times 1.01. I add that up, and I get that 1 mole of ammonia is equal to 17.04 grams of ammonia. So my second step, as always, is my factor label problem. So I want to know the number of grams. I've been given the number of molecules, and this time my first goal is to get rid of molecules. So when I set up my picket fence, I'm first going to use the Avogadro's number conversion, right? And this time, since I want to get rid of molecules, I'm going to put Avogadro's number on the bottom of my fraction so that I can cancel out molecules. And Avogadro's number is always equal to 1 mole of whatever you're talking about. So if I solved right now, I would be in moles, which is not what I want. I want to be in grams. So whenever I'm dealing with grams, I got to use my molar mass information. So this is going to turn into a fraction. This time moles are going on the bottom because that's what I want to cancel out, which leaves me with my units in grams. So I do my multiplication and my division. Again, these numbers that are in scientific notation, unless you're using that EE button, need to be in parentheses. Otherwise, you're going to get a really weird, large answer. And if you calculate this all correctly, you should get 8.52 grams of ammonia. So if you get 8.52 times 10 to the 47th or times 10 to the 48th, apparently we still have not resolved how to enter scientific notation in your calculator. That's not okay. You need to make sure your answer is just 8.52 grams. Okay? So as you start to look at some of these problems in class, you're going to realize that they're all sort of mixed together. Some of them are going to be like the first example, where you're going from grams to molecules, and some are going to be like the second example, where you're going from molecules to grams. So you're going to need to think about when you use each type.